So today we're going to be looking at finding the Maclaurin series expansion and then using our Maclaurin series expansion to approximate the true and approximate relative errors. So this is a very straightforward example. It's not very much different than what we were doing with the Maclaurin series, but it requires just a couple more steps. So this question itself says use the first three terms as you can see here. And we've actually already done that, or if you're not familiar, in the other videos that I've posted, I've kind of showed how to do that, but if you're not familiar with that, there's no worries. I'm going to show you how to do that in this video too. So to begin this question, it says find the value of ln 1.1. Okay, you need to find the value of ln 1.1 using the first three terms. So what does this mean? You can't simply plug in ln 1.1. Instead, we need to take a look at our original function, f at x is equal to ln 1 plus x. What really concerns us here is the value of x. We need to find what the value of x is in order to start this question. So it says find the value for ln 1.1. So ln 1.1 is what we're actually looking at right now. And we're just going to use simple algebra to work backwards and find what the value of x is. So if we have that ln 1.1 is actually the value that we need to solve for, and we need to find the value of x. If you look inside this bracket here, we have 1 plus x. And then if we look here, we see that 1 plus x got us the value of 1.1. So if you simply just do 1.1 subtract 1, we're going to see that we get 0.1 here. And if you look here, 1 plus 0.1 will give us the value of ln 1.1. So you can go ahead and you can say that x is safely 0.1, and this is going to be very useful in determining the approximations. So that's the first step. So the second step to the question is now we need to find the Maclaurin series. So the Maclaurin series, this is a very straightforward task. The first thing you want to do is you want to start by evaluating the function itself, or just writing the function. So ln 1 plus x, this is the general function. And then because it's a Maclaurin series, this indicates that x is equal to 0. You need to evaluate the function at x is equal to 0. So if you evaluate ln 1 plus 0, you're going to get that you're evaluating ln 1. And if you evaluate ln 1, you're going to get a value of 0. Then you're going to go ahead and you're going to take the derivative of this. Simply take the derivative of ln 1 plus x. If you're not familiar with doing this, I highly recommend you take a look at your derivative rules again. And that's going to make your life very straightforward, as the Maclaurin series heavily depends on this. So here you have 1 over 1 plus x. You simply just plug in 0 here, so you're just going to get 1 over 1, straightforward. And then I'm going to go ahead and I'm going to do this for the first three terms we're going to find. So the next thing we're going to get is if you take the derivative of the previous term, we're going to get 1 plus x squared. And then we simply evaluate this. We're going to get negative 1. Okay, it's straightforward. And then if we go ahead and then we do it for the third derivative, we're going to get 2 over 1 plus x cubed. And then if you evaluate the third derivative at 0, you're going to get 2. Okay, so now we have three terms that we can work with. And the reason I say 3 and not 4 is because the 0 here doesn't apply to us. We're not concerned about the 0. We have three real terms here. So this is the good terms. And then this is what we're going to be using. So the question itself says find the value ln 1.1 using the first term, the first two terms, and the first three terms. And then for each term you're finding, or the first terms, you need to compute the true and approximate percent relative errors. Okay, that's pretty straightforward, but what does that really mean? Okay, so before we start, what is the true value? Or the true, here in the question it says, what is the true percentage, right? So the true relative percentage, or the true percentage that we're concerned about, we'll call it ET. And then this is the notation you're going to be using for the true value. Then I'm going to represent this, call it the true value. The true value is in terms of a percent in this case, and it's equal to the original function you have, or the term it wants you to evaluate it as. So we were told to evaluate ln 1.1, and the value of ln 1.1, if you go ahead and you plug this in your calculator, you're going to get a value of 0.09531018. And all I did was I evaluated this in my calculator. So you would, to find the true value, you would just go ahead and you would do this minus, and then you would subtract it by the number that you just calculated, or the, in better words, for the term you just found. So we'll call it T1, T2, or T3 of the Maclaurin series, and then over 0.09531018. So this might seem a little wordy, so instead I'm just going to go ahead and now I'm going to do an example. So let's do the example for the first term. The first term is very straightforward. So this is using the Maclaurin series. So Maclaurin. So we're going to approximate ln 1.1 using the first term. The first term we have up here is we have x, or in this case we have 1. So actually let's go ahead and we'll write out the Maclaurin series expansion. So Maclaurin series expansion. So Maclaurin series expansion is going to be very useful for us to understand what we're doing and where we want to get to. So f at x, in this case, it's equal to c0 plus c1x plus c2x squared. So all I'm doing is I'm writing the Maclaurin series expansion. This is nothing new. If you're not familiar with this, I highly recommend that you do take a look at the Maclaurin series expansion. But at the same time, you can also learn the Maclaurin series expansion just from this video alone. And then if you look here, you have C0, C1, C2, and C3. These represent the coefficients, and we found all these coefficients. This here is C0, this here is C1, this here is C2, and this here is C3. Okay, that's very straightforward. So we can conclude that f at x for the Maclaurin series expansion is 0 plus 1x, which simply can just be written, in this case, I'm just going to simply write this as x. Oops. Let's go ahead and write that as x. And then for the second term we have here, we have negative. So we have negative 1. So just put negative x squared over 2. And then C3, what do we have for, we have 2 for C3. So it's very straightforward. Plus 2, x3, 3. Okay, so here we have, we wrote down 4 things, right? But as I said at the beginning, 0 doesn't concern us, so we're not going to use the 0 as the first term. Instead, we're going to use the x. If we go ahead and we're going to start here, we're going to call this step 1, and this we're going to start by finding the first term. So first term. Find the first term. Okay. So the first term we have f at x is equal to x. And all I did was use the first term of the Maclaurin series. And we said that x is actually equal to 0.1. And if you look up, we discussed this here because we said that if you were to look at ln 1 plus x, we can just work backwards and find that x in this case is 0.1. So we say that x is 0.1, meaning that the approximation using the Maclaurin series is 0.1. This 0.1 it's approximately close to 0.09 and the number we calculated here, but it's a little far off. So what we need to do now is the question says calculate the true and approximate. So ET represents the true value. To find the true value, we talked about this. It's a simple equation you use. So you use the value that you were told to calculate, and we were told to calculate ln 1.1. So you would do 0.09531018, and then you would subtract this by the Maclaurin series for the first term, 0.1, and then it would be all over 0.09531018, and then you would multiply this by 100%, and then if you do this, you're actually going to get a value of 4.92%. So this right here, this becomes our true percent, right? So this is our true percent. And then our next thing we're going to do is we're going to calculate our relative percent. To calculate your relative percent, you're going to use the approximation you found using your Maclaurin series. And then our approximation here we found was 0.1. You're going to use your approximation you found and you're going to subtract it by the previous approximation. In this case, this was our first term we found, so there is no previous approximation. Therefore, we can say that it's not applicable. You can't find the relative percent for the first term. And then this concludes everything we need for the first term. Now we're going to take a look at the second term. So the second term. So the second term we're going to be working with is we're going to write the Maclaurin series expansion for two terms. So the first two terms we're going to get is x, which was the first term. And the second term we're going to get is actually should be negative minus, and then here we found this, it was minus x squared over 2, right? Because if you look above, we found it here for the second term. So it's the first with the second term. And then if you go ahead and you plug this in your calculator, you have to use 0.1 for the value of x. And then if you work this out, you're going to get 0.1 minus 0.1 squared 2, and then work it out in your calculator and you're going to get a value of 0.095. So this is your approximation using the Maclaurin series for ln 1.1 using two terms. Simply to find the true value, true percent error, you would go ahead and then you would use your ln 1.1. So I'm going to make this easier. I'm going to say, actually I'll just go ahead and write it out. I was going to write ln 1.1 there, but it might be a little confusing for some, so I'm just going to go ahead and write the actual value. And then you would subtract it now by this term, the term we just calculated. So you subtract it by the term you're on, and then you would go ahead and then divide it by the ln 1.1 term, and then multiply it by 100% to represent percent, and then you would get 0.325%. So this would become the true value. Now the relative, now we can go ahead and we can find the relative approximation here. So as I mentioned, you got to use a term you're on, which is 0.095. And then you would use this term, and then you would subtract it by the previous term you calculated. The previous term you calculated was 0.1 using only one term. So you would do 0.1, and then you would divide this by the term you're on, 0.95. multiply it by 100% to showcase the percentage. And then if you do that, you're going to find out that you're going to get 5.2. So also, just another thing to note, your top, I should have mentioned this a little earlier. So you can go ahead and you can say that this is an absolute value, right? Because we're dealing with percentage here. So even if you were to get negative 5.2, you can just go ahead and write 5.2 because we're dealing with an absolute value here. And then this concludes that. You can go ahead and you can conclude that the approximate relative error is 5.2 using two terms. So now we only have one more term we need to work with, and that is our third term. So if we go ahead and we start the third term, so we're going to go ahead and we're going to start the third term here. So using three terms. Okay, using three terms. So this shouldn't be that much different. So we use our x, we've already done that, x squared, and then 2. And then for our third term we have, let's go ahead and take a look at what our third term is here. So our third term we said was plus 2x cubed over 3 prime. So plus 2x cubed over 3 prime. So simply, if you forgot what prime is, all it means is 3 prime just means 1 plus 2 plus 3. Where 2 primed is 1 times, or sorry, this was multiplication, 1 times 2 times 3, where 2 primed is 1 times 2. If you're not familiar with primed, you can also watch some other videos on that if you need more of an explanation, but that's the simplest way to represent prime. So if you do this, you're going to just go ahead and you're going to plug in your x values of 0.1 minus 0.1 squared over 1 times 2 here, plus 2, 0.1, right? So 1 times 2 times 3. And then you're going to get, I'm just going to go ahead and quickly plug this in my calculator and see what we get with this. We're going to get a value of 1 times 2, 0.1, 3, 2 times 3. Okay. So if you go ahead and you plug this in your calculator like I just did, you're going to get this. You're going to get 0.095, and you're going to get a bunch of 3's. Let's see, 1, 2, 3, 4, 5, 6. So you're going to get 6 3's, 4, 5, 6. Okay, so this is your approximation you got using your Maclaurin series. And then you just go ahead and you repeat the same process. You calculate ET here. So you use your original value. That shouldn't be an issue. We said that was 0.09531018. Subtract this by what we just calculated here. 3, 3, 3, 3, 3, 3, and then divide it by ln 1.1, 1018. Multiply this. And then what you're going to get if you do this, you're going to get 0.325%. And then I should also note, as I mentioned, this is an absolute value. And then that's good. And then we're going to go ahead and we're going to find the relative percent error. So we're going to use the number we just calculated. So that is 0.095333333, and then you're going to subtract it by your previous approximation, which was 0.095. Right. Oh, my apologies. I think I made a mistake here. Let me go ahead. I need to quickly check this in my calculator. 0.095310180, 2, 3, 4, 5, 6, 0, 95310 0.0 95310 0.09. Okay, so what I always like to do is I always like to double check my calculations, because sometimes it's easy to just go ahead and screw something up, because right here we're working with just it's high precision numbers, and it's easy to make careless mistakes. So my best advice is probably, if you have time or you work fast, to double check your answers. This is probably the smartest thing you can do in order to make sure that you're getting the right answer. Just go ahead and double check using your calculator, because sometimes people make quick mistakes. And if you make a mistake, it really becomes difficult, because as you can see, your answer is dependent on your previous answer, so it can really get messy if you start making mistakes. And depending on who your professor is or how your professor likes to mark, they can really take away a lot of marks. But if they're marking for the process is the same. So here for the relative percent, you would do what we just talked about, and then you'd subtract it by your previous one we found. And then your previous one we found was 0.095. Okay, so 0.095, and then you would go ahead and then 0.0. So you just divide it by the one you're currently on, multiply it by 100, absolute value here. And if you go ahead and you do this, I'm just going to go ahead and punch it in my calculator. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and if you go ahead and do that, you're going to see that you're going to get 0.35%. Okay, so let's take a look at the question. So the question said to find the Maclaurin series. We've done that. Find the value ln 1.1 using the first term. Yeah, we've done that using the second term and the third term. And then compute the true and approximate relative percent for each approximation. Well, have we done that? If you look at the first term, we've calculated the true value for that. We weren't able to calculate the value of the relative here. So because it's not applicable, you can't really do anything here. We found the value for the second one for the true. We found the relative for the true. The third, we found using three terms, we found the relative and the true error percentage. So you can go ahead and you can conclude that this question is done. And if you're going to take away anything from this question, you're going to see that your initial ET actually converged. Your percentage between your ln 1.1 and using your Maclaurin series kept getting smaller. So the first time we got 4.92%, whereas when we used two terms, we got 0.325. Before I show you the third term, you got to keep in mind that the whole purpose of this is the more terms you use, the smaller your difference is going to get. If we look at the third term, we're going to see that we got 0.024, which is less than 0.325. And then same thing is happening for your EA. Your EA is going to keep getting smaller. So this is when you know you're really doing these questions right. If you actually ever think you're messing it up or something is going wrong, the whole purpose is, are you converging? If you're converging, are your numbers getting smaller? Are they getting closer to 0? If they're getting closer to 0%, then it means that you're getting closer to your ln 1.1, in this case your true approximation, and that's the whole purpose. That's the whole take home of this question. You're just using a different method in order to approximate the value of ln 1.1. If you're using, for example, 10 terms, you're eventually going to get near 0, and that's why we use the Maclaurin series. That's why we use the expansion in this case in order to test the true and approximate relative percentages. So that basically concludes this video. If you liked it, please make sure to leave a like, comment if you have any suggestions, and make sure to subscribe. If you'd like to see more examples of the Maclaurin series done, just let me know. Leave your thoughts in the comment section below. And that basically concludes this video. Thank you for watching.